All right. Well, hello, AP Stats. Hopefully, you got a chance to read through that document that I sent out. We basically just need to cover these next three sections of the notes just to finish up Unit 11, since that will be included on the AP exam. Unit 12 will not be included on the AP exam, so I will not be including that on Schoology. I mean, if you are just dying to go through Unit 12, let me know and I can share some materials with you, but I won't be posting that for the entire class. In addition to that, I'm going to make Unit 11's test just a take-home test. That'll be posted on Friday at 8 a.m. for you. You'll have until Monday at midnight to get that turned in to me so that I can give you some feedback. And then next week we will start our review for the AP exam. And then I'll also have probably quite a bit more information to share with you about that AP exam, since they've said that April 3rd, which is this Friday, is when they are basically going to release the test dates and all the other information that we need to kind of make our plans. So that being said, let's kind of get into these last three sections, and they're pretty short, pretty easy sections to get through. I've updated the homework assignments so that they are now due this Friday by midnight. That way you can get those submitted and get any feedback that you'd want to on those. And then obviously you're aware of kind of how the grade situation works. But if you guys do have any questions, feel free to email me or come to my office hours any day, 10:30 to 11:30. Okay, so what we need to talk about, we just finished up residuals, I believe, right before spring break. So we were talking about kind of measuring how well our line predicted either being an underestimate or an overestimate. So that kind of ties directly into what we'll talk about in this section of notes about how well the line fits the data. And there's two different measurements that we'll use for how well the line fits the data. One is what's called S, the other is what's called R squared. And this section of notes just focuses on what those are and how to use those when interpreting them. So first off, S represents the standard deviation of the residuals. In other words, it tells you how far the residuals vary on average from your prediction line. To find that, you'll say that you'll take S is equal to the sum of your residuals squared divided by n minus 2. And oftentimes, you're going to be given that S value and just asked to interpret more times than not. So as far as calculating it, obviously you can use your calculator to do that. I don't remember if I've even given you any questions on calculating it, but if there are, I can for sure walk you through some of those, especially during those office hours. As for interpreting it, we will interpret it as the typical distance from the regression line. And so when we on this first one, let's talk about it. For the can tapping example, and I'm sure you remember this example, we were tapping on the cans of soda to figure out kind of how much soda would be left after so many taps. The standard deviation of the residuals was S is equal to 5, and this was a typo. It should have said 5 milliliters. So there is a label for S, and in this case we are measuring the soda in milliliters. It then asks us to interpret this value. So what we would say is, on average, the residuals were about 5 milliliters off from the regression line. Okay. So for the second question, suppose that we wandered in during the can tapping experiment and found a partially full can. Without measuring the contents, how could we predict how much soda was left in the can? And the answer is there isn't much you can do. You really need to know how much time the can was tapped for in order to make any sort of prediction about how much soda was left. So then how much better would our predictions be if we knew how long it had been tapped? Well, now we can use our regression line to predict how much was in the can. Within about plus and minus 5 milliliters of accuracy. So you could guess it within a range of about 10 milliliters, 5 in either direction. That's pretty darn accurate if we're being honest. So that kind of talks about S. So S again is talking about your residuals and the average distance they are from your regression line. The next one that we're going to talk about is r squared. So coefficient of determination is what that is. R squared is the fraction of the variation in the values of y that is accounted for by the least squares regression line. In other words, it's measuring how well your line predicts the data, which is what this section is all about. So as far as calculating and interpreting r squared, first off, to calculate it, same as you would for just a linear regression, go ahead and do your linear regression, write down what your r value is, and guess what? To get r squared, you just square it. Now the interpretation, kind of a form sentence here, and it is kind of a little bit kind of blocked out, kind of how it's supposed to be written. So make sure you do kind of follow that. But it would be to say that about blank percent of the variation in the response variable is accounted for by the linear model. So whatever r squared is, you just fill that in the blank and make sure that when you're talking about the response variable that you're doing that in context. Which kind of brings up the question then, if we can find r squared using r, then kind of what is the relationship between those, and kind of how is r squared also related to s? So the first question, how is r squared related to r, besides just the fact that it's being squared? Well, first off, r is the strength of the correlation. So when you're looking at the strength of the correlation, how closely do your points kind of fall into place, that is what r is describing. R squared is the strength of the linear model. So for one, you're just looking at the data points. For r squared, then you're looking at how well does your line fill in all those data points. So one is focused just on the points, the other is focused on the line. As for the second question, how is r squared related to s? Well, both measure how well the linear model fits your data. So in a sense, they do the same thing. I guess the one key difference, oops, a little too close to that button there. The one key difference is that S has units. So when we talked about S in the key tapping example, we talked about the fact that it was 5 milliliters off from your regression line, whereas r squared does not. So that is kind of the big difference between the two, as well as obviously the interpretations and kind of what they represent, but they essentially measure the same thing. All right, well, yeah, like I said, pretty short, pretty quick, pretty easy section of notes to get through. At this point, we're going to have kind of 2 more sections. The next section is definitely the longest section, so just be prepared for that. That'll probably be a solid 25, maybe even 30-minute video. I'll try to go as quickly as I can. And then the last section is a pretty short and sweet section. It's just a single page. Won't take us long to get through. So, all right. Well, I wish I could have gone through this with you in person, but I guess this is next best thing, and we'll get you ready for that test and get you ready for that AP exam, and looking forward to making sure you guys are ready for it. So have a good one.